Okay, let's get started. So, what's due today? Lab 1 and assignment 1. So, I had no one in my office hours on Wednesday, so I assume everything is hunky-dory, right? Any questions about the lab or the assignment? Yeah?
Okay, I'm having this issue right now where I get one decimal point right after the answer. How can I increase it to 4? Is there like a simple answer or is it more complex?
So I didn't explicitly teach that in the class. So whenever, so there's no way I can teach everything in the C++ language. But if there's something that you need and you don't know necessarily how to do it, what should you do? We'll consult me or the TAs, but in general, what else could you do? Yes, search it on Google. So like, how do you format to 4 decimal places? And then what should you do after that? Cite it. And how do you cite it in the code? As a comment, okay? I got it from this place, and here's the code that I've written. It's not copied and pasted from there, okay? Yeah. Other questions about the assignment? Yeah. No. So, yeah, so I don't care whether it's like MLA, APA, I don't really care about that kind of thing. I just want it to be so that the grader or the TAs or me can see precisely where you got it from. And pretty much in this class, you're just going to, if you're going to find anything, it's from the internet. So just put a URL. Then just say, if you have some code related to formatting to 4 decimal places, put a comment saying, I got this from, paste the URL there, you're all set. And the code has to be your own code, of course. But the idea came from there. There's no penalty for that. Yeah.
Is it okay to just like include a list of links for the references?
Yeah. So what might be better is if you do have a lot of links, put them in comments near where they're used. So instead of like all at the top of the file, because it might be hard to associate what you got from where, but just put a comment near where you actually use that kind of resource. Just like in a normal paper, you would put the citation right after you use anything from that resource. Other questions about the assignment? Content questions about the assignment? Do I accept submissions by email? No. So if you send me an email with your submission and it's not submitted on Blackboard, what do you think is going to happen? It's not going to be graded, okay? So submit it on Blackboard and everything will be just fine. Other questions? Also, there will be no issues with academic integrity violations on the first assignment, right? Okay, so I run an automated script that checks for software similarity, and I've checked a few submissions already, and some of you just need to be sure that you are writing the code instead of getting it from somewhere else, working with friends, that sort of thing. So just make sure it's your own code. Okay? Any other questions about the assignment? Yeah?
If we are getting code, like lines of code from somewhere else, all we have to do is say it, right?
No. So you have to write the code yourself, but you get the idea from somewhere else. If you write it yourself, there's virtually no possible issue. So just write it yourself, but get the idea from somewhere else. That's totally fine. Yeah?
So if you like look up a different form of the code, like a different program, a different name, and use that as a model to make that.
If it's significantly different, then it's okay. Other questions? Yeah?
Yeah, if the tutor helped us with a lot of the code, do we have to cite him for
Yes, because he's a resource. He or she is a resource that you've used. So just say, and if you happen to not know who it is, just say, I got help in the tutoring center or from the TA. Actually, you don't need to cite help from the TA or me, but if you got it from anyone that's not one of us 4, then you have to cite all of that.
Okay, cite the majority of how I got my ideas from.
So then cite it.
Okay.
Yeah.
So if it was like for you have to say, or
If it's from me or from the slides or from the TAs, yeah, that's not needed. Or from the book. You don't have to cite the book.
so just leave it if it's just like from you don't have to comment or.
Yeah, you don't have to comment if it's any one of us four or from the book or from the slides. Yeah, you don't have to do that. Yeah.
The only one, like, I'm not sure, so they use a consistent flow for pi, and I copy
Yeah.
the number, like for pi.
Mhm. Yeah. Although I didn't intend for you to make a constant in C++ because we haven't covered constants yet. But I suppose it's okay. I intended for you to use one of the header files to import pi a different way. That's what I intended. Other questions?
I was gonna say, when you look up how to put in pi, it actually says that it recommends, most websites recommend that you make it constant.
Right. So did we cover why that's a bad idea? Because you're not going to be using the same pi necessarily throughout your program. And if you want to add a few digits to the pi you have, any place that you have the constant that you make, you have to change it in every single place. But if you use the system pi via the way that I showed you, then it'll be the exact same throughout your program and you don't have to change anything. So either way is fine. It's just think about it from a maintenance point of view. Yeah.
We forgot our percentage of comments, can we just submit another?
Yeah. There are unlimited submissions, but remember the last submission is the one that counts. Yeah.
What's the difference between writing it as like math.h or C?
Great question. So the header files that end in .h are from the C programming language. And the headers that don't have a .h but are prefixed with C at the front, those are the C++ versions of the same header. So if you actually dive down into C math, for example, you can actually see an include from math.h in there. So it's just an upgraded version in some sense. But in terms of functionality, they have no difference, as far as I can tell. Other questions? Okay, so let's talk about strings. So last time we were talking about characters and strings because we want to be able to print text or manipulate text, possibly. And the two things that we dealt with are characters. So those are just single characters with a single quote on both sides. And then strings are basically a generalized version of that. Multiple characters, or 0 if needed, with double quotes on both sides. Okay? So sometimes you may want a character and sometimes you want a string. So maybe we'll get to this in a while, but one of the main purposes of using a character that I've used is if you want to present a menu to a user. So you present a list of options to the user, and you want the user to select, hey, do you want this option, this option, this option, or this option? Well, how do I check whether the user entered the first or second or third or fourth option? Well, what could happen is I required the user to enter a whole bunch of text in order to say, yeah, that's the option that you wanted. But what if they happen to enter it maybe one character off? Or maybe that it's a lot of text for the user to enter. If you require instead that the user enter one character, then it's easier on the user and it's easier for you to check because now you just check whether this one character is equal to this character, and then it's much easier. So that's a case for when you want a character. And for a string, it's just if you want to print out a whole bunch of things, or if you're working with files and you need to read in text, then you may need to work with a lot of text at once instead of just individual characters. So let's try to understand what string is. So there's a header file called string, oddly enough, that you use string objects. But I want to mention one thing related to this. So I have a program right here that just includes IOStream, so it doesn't include string. Using namespace, I have a string here. Maybe let's print hello. Then I try to run. Then it prints fine. But I didn't include string. But the slide said that I must include string. So what happened? Yeah. What, sorry?
Is it that you're not creating the string?
No, I am creating string objects right here. Yeah.
Is it part of IOStream?
Exactly. So this is what I call a header chain. So if you include a header like IOStream, then it can itself include other header files, and then you get those for free. So if you dig deep enough into IOStream, you can actually find an include to equivalently the string header. Not exactly the same, but it's the string header essentially. So if I do explicitly say, yeah, I want the string header here, then this, as you might expect, is a redundant include, way in the back.
Why don't they put everything in IOStream then?
Yeah, so the issue with that is if I need to parse the entire C++ library in order for this to work, because remember, the preprocessor literally moves the code over to my program and keeps what is necessary from there. If I need to move the entire C++ library over, that could take quite a long time to just even compile. So that's why not everything is included in IOStream. So I forget what the term is, but what you kind of want to do in programming and anything related to problem solving in general is you have to compartmentalize your thought process. So if I have everything type of header where I include every single thing in this one header, then if you want to maintain that header file, then you have to remember all of the includes from there. Or if you bunch a whole bunch of includes together, and then maybe some other things, you need to manage that as well. By having some parts of the library in separate headers like this, then you say, okay, this header only is responsible for anything related to strings and nothing else. The CMath header is entirely related to math functions. IOStream has something to do with streams and input and output. So it's like you are compartmentalizing your thought process in designing the library. But think about it for a second. IOStream relates to inputs and outputs. But if the user enters text, that sounds like a string to me. So it makes perfect sense then for IOStream to include string, because it's necessary for the function of IOStream. So you have to think when you're designing your program, what things do you actually need and what things are not necessary? So for IOStream, for instance, I don't think computing the cosine of a float, for example, is needed for input and output. Okay? Does that answer your question? Cool. Other questions? Yeah. How do you tell the difference between? I'm not sure what you said.
If it has to work, if the code has to work, how do you tell the difference between trying to people?
I'm not sure what he said.
Basically, what he's saying is like, if there's a certain way how to do coding for like a certain objective, how can there be any differentiation between coding?
So, good question. So we're at the point here where there's only one type of way to approach it. Maybe that you do some calculations earlier than later, and maybe you format the code differently. You maybe output things in a different order. So there's not much room for different types of approaches to solving a problem, because all we're really doing in this program, for instance, is we're printing a string. Well, the only way we know how to print a string is cout. And there's only really one way we've seen how to do cout. So there's not much you can do here. But as we go along and make more complex programs, we'll start to see multiple approaches appear. But we're not at that level yet. Other questions about this program? Okay, so I just wanted to caution you about this, that sometimes even if it says you must include this, then you don't really need it. If I remove the cout statement and removed IOStream, then it's okay because I included string. But if I didn't include string, now it's complaining that I didn't include the right header file. But if I went back and included IOStream and removed string, then it'll say it's okay. So therefore, the string header is in IOStream somewhere. Okay, cool. So as you might expect, the way we declare a string is instead of like int something, we have string something. Not much difference there. And remember the assignment operator for integers and doubles and floats that we've seen, where you put the thing on the right to be assigned to the thing on the left, the variable on the left. Here it works exactly the same way. Either you have a string variable on the right side being assigned to the one on the left, or you just put a string literal, which is just something between two double quotes. It does the exact same thing. So here, name at the beginning, what do you think the value of name is here? What value does a name hold, do you think?
What do you mean?
So like if I wanted to print name right after this initialization, actually we can actually do that. So if I just declared the string by itself and I cout s, what do you think is going to be printed? Yeah.
It's going to be whatever was in that memory location driver.
So that's a possibility. What's another possibility? Could be an empty string. So let's just see what happens. Well, it printed nothing. So why do you think that is? Yeah. Yeah, but one of the quiz questions was about ints, and that when I have like int val and I don't explicitly initialize it to some value, then we can't necessarily say whether it's 0. But here we can always say that it's the empty string. It has no characters in it. So what do you think happened here? So there's actually something pretty deep within the language, which is, so the metaphor behind C++ is that if it has no runtime cost, there's no runtime cost associating with doing an operation, then we initialize it to 0, or the default value, whatever that is. So if I have an integer and it costs me nothing to set it to 0, then it will be initialized to 0. But if it does incur a runtime cost, then I won't set it to 0. It'll be just whatever the location was before. So here, what happens is that the string needs to allocate memory in the computer, some amount of memory in the computer. And I can't predict necessarily how much space that's going to be needed. And so because of that, I can't initialize s in this case to be the empty string, to be whatever data that was in that location before. So because it doesn't incur a runtime cost, I can set this to be the empty string, which is why we always print the empty string here. But in some situations, if I have an int there instead, it may print some random number, some whatever was in that memory location before. So yeah, so remember that here it's going to be initialized to the empty string. But although that's not really that important because we hardly ever deal with the empty string in this class. But so just remember the assignment operator, assign the thing on the right to the thing on the left. And if you just cout the string, it'll work exactly as intended. It'll print the value in that string. Okay, so if we want to input a string to from the user, then we could just use cin again. So instead of inputting an integer or a float or anything like that, I can just cin a string and it'll work exactly the same as you might think. But here it says, reads in a string with no blanks. So what do you think that means? So let's just see what happens. So if I enter a string, if I say user enter a string, and I do this, and then I print out the string. What do you think would happen if I tried this string? So CSE space 100. What do you think would happen? So you think there's no space? Any other ideas? What's that? Truncated to CSE. So any other ideas? So it'll remove the 100 space? Yeah. Well, the space is technically a character, so it could be part of the string. So maybe it reads the entire thing, CSE space 100, and it prints everything. So any other ideas? Well, so how can I check what happens here? Press enter. Oh, well, it printed CSE and no space. I don't see a space there. So what do you think happened? So what happened here is the way that CN works by default is that it does what is called tokenization. So tokenization is you get a whole long string and you break it up into chunks separated by some delimiter between the chunks. And by default, CN's delimiter is a space. So if I CN'd two strings, so let's just say I have two strings here, and then I entered both of them and printed both. And then I try the exact same thing. So if I do CSE space 100, what do you think would happen? It'll print, well, think about it for a second before I press enter. Well, it seems like S is going to get the CSE part, and S2, because the space is a delimiter by default, S2 is going to get 100. It's not going to get the space. So what do you think this cout is going to do? It's going to print CSE right here, then immediately print 100. Do you think a space is going to be printed between? No. In some languages, like Python, it would be. But in here, it's not. And we can actually verify this for ourselves. So if I enter this, it prints without a space. So what if I did want to put a space between S and S2? A string that corresponds to a space. So I put a space string like this, and then I have to put this again, and then I can actually print both of them with a space. So if I do CSE space 100, and it prints with a space between. So let me ask you another question. So what if I did CSE 100 without a space as the input? When I press enter, what do you think is going to happen? Well, let's just see what happens. It's got to input the next string, because the CN statement is expecting two strings here. And I've only entered one because I didn't put a space there. And so if I enter another string, then it prints this. Because the first string was CSE 100, no space. Then another was the next string, no space there. So it prints CSE 100, space, and then the next string. What about this? So we got to think these things through if we're going to be programming in the general case. What if I did CSE 100 with a space at the end? What do you think is going to happen? So is it going to ask me for another string, or is it going to immediately print? It's going to be immediately printed. Okay. Well, let's see. It didn't print. I actually thought it would print, but why do you think it didn't print? Yeah. Well, the space, remember, is the default delimiter for CN. So why is it waiting for another string? Yeah. Okay, well, so this seems to me like CN must take in a non-empty string. It doesn't accept empty input. So if I push enter here, it actually doesn't accept the input, because by pressing enter that just now, I was trying to intend that this is the empty string, but it's actually not accepting that. So, but if I do put something there, then it'll actually finish. So how can I figure out whether this is the intended behavior of CN, or do I have some weird C++ library? How do I check that it only accepts non-empty inputs? Just search it. Look at the documentation for CN and see. Maybe it requires that all the inputs be non-empty. Or maybe you can set something to say, yeah, you can have empty input too. So this was a surprise to me as well. Yeah. Okay, great question. So what is the null terminator? As a refresher? Yeah. \0. And what was the purpose of the null terminator? Yeah. Right. So it says, here's the end of the string. Because remember, a string can have any length that it wants. Integer has a fixed size, but a string can have any length that it wants. So because of that, we put a null terminator at the end to say, yeah, this is where the end of the string actually is. So the null terminator here is created on the back end of string, and we don't manage it ourselves. Yeah, so it's just for the implementation of string to say, yeah, the end of the string is here, but we don't actually care about that. And we'll never deal with the null terminator here. Yeah. How can a what? Size of a string. So there are what are called methods, but we'll talk about methods maybe in a month or so. But there are things that you can set on the string to say, I'm going to reserve this size. So I'm going to reserve 80 bytes for this string immediately. But if I wanted to, so there are multiple ways that you could increase the size of the string. One is by saying, at the beginning, the size of this thing is 80 bytes. But another way is to say, I'm going to append onto this string maybe a few characters or something. So that's another way that you can increase the size of the string. Yeah.
How could we make the common overflow
with a string, you can't, other than running out of memory on your computer. So because remember, this, although that's not completely true, it was more true back in the 80s and 90s. But the reason why you can't cause an overflow easily is that the size of the way that you hold all the characters in a string is basically intended to be the size of an integer. So the size of integer number of characters are allowed in a string via something we'll call arrays, but we haven't gotten to that. So basically, remember an integer has around 4 billion possible values. So you could have a string of 4 billion characters. And if you need any more, then you may have some problems there. So that's why it's not easy to run out of memory with a string. But it is possible to do so. Yeah.
What if you don't want to enter S2, S3, and all those values, and you just kind of want to enter like a really big value?
Oh, one long string, and then what do you want to do with the string and just print it or break it up into the chunks? Because the answer is different.
I mean, print it, but with the space too.
So like you enter the entire input with spaces and print the entire thing with spaces as well?
Yeah.
Okay. That's actually the next slide. Actually the next bullet point. So this is the way that we just saw how to do this. But if you want to do what was suggested, it includes spaces. So basically everything up to where you push enter, you do something called getLine. So it's not the same format as CN, but it gets the entire line up to when you push enter. So let's see what happens there. So enter a string. So we can't do the CN thing anymore because that is by default going to stop at the first space. So we need to call instead getLine. So the great thing about cline is that it gives you some things you may want, like this one. So I push enter. Then it expects based on this slide, it expects cin here. So getLine works by specifying where you're getting the string from, and the second argument is where it's going to be placed. So here it says, I'm going to get all my input from cin, getting it from the user, and stir right here is the string that we declared earlier. So when it's finished getting the line from the user, whatever text was entered is going to be placed into stir. So it's going to do an assignment to stir. So if we do cin, and then, so now we have one string to work with, s, and then we want to input to s, and then print out. So let's see what happens here. So if we enter CSE space 100, it prints the entire thing. So now it's a kind of implementation decision and part of the artistry in programming here. Are you going to expect an input that does have spaces, or should you expect one that does not have spaces? So it depends on what type of thing that you're trying to build. If you have a menu, maybe you're not expecting spaces from the user, but maybe you are. Yeah.
Can you use getLine to put in integer functions and
What do you mean, put it into integer?
like you know how cin basically takes in whatever the user says, and you can put that number into calculation or whatever.
Mm-hmm.
Can you do that with getLine too, or is that
getLine only works with strings. So it inputs a string. So you can't really input to, so you can actually check. So if we try to type getLine, so getLine, oops, let's do it this one time. So if we scroll up and down, so we see, well, this is, which one is it? It's one of these. So you can actually see on all of them that so if you look between where the comma is, right over here, I can't really point to it, but it says something like basic iStream, and then after a comma, it has something called basic string, whatever that is. So the iStream corresponds to cin, and basic string is just a string. So in all of the cases here for getLine, we see that the first part of it is an iStream, and the second part of it is a string. So in fact, based on this, I can't use getLine for an integer. So I must have a string there. So you may wonder, well, how do I convert a string into an integer? So like I have a string and I want to convert it to an int. How do you actually do that? And so I encourage you to look up how to do that. And it's actually not that hard. But you can't do that with getLine is what I'm saying. Other questions? Sweet. So that's getLine. Okay. So if we wanted to do this with characters instead, then we can, of course, just use cin, just like always. With a character, it works exactly the same. But there's a special method, as it's called get. So get reads any single character off the input. So let's just see what happens here. So if we use a character instead, so char c, and then let's say that we c equals cin.get. So you can actually see from this that it returns an integer, but I'm saving it to a character. Is that an issue? Why is it not an issue? Yeah. Exactly. I mentioned last time this ASCII table has a correspondence between what a character is and what an integer is.
what does that mean?
So that just means that if you look back on the slide about characters, so when you have a character, it stores an integer on the back end. So characters are integers. They're exactly the same. So what happens here is it says an integer, but a character is an integer. So you can actually do this saving here. So, but let's see what happens. What if I wanted to enter our favorite string, CSE space 100? and I output that one character, what do you think is going to be printed? Just the C. And in fact, that's what happens. So what happened to that rest of the input, that SC space 100? What if I did this part again? In fact, I can just do cn.get instead. What if I did cn.get twice? So what do you think will be printed? So I'm calling get. So this one obviously is going to be that capital C. But what do you think this second one's going to be? So how can I check? Run it. So let's see. So let's do CSE space 100. And it printed 6783. Interesting. What do you think? What do you think 6783 corresponds to? Yeah. The two ASCII codes for 67 correspond to C, and 83 corresponds to S. But why is it printing an integer in this case, and not printing the actual characters? What does cn.get give us? Integer. But when we did the saving over here, then we printed C, it printed the actual character. But I thought characters were integers. So if I did this and I left this second cn.get, what do you think will be printed? C83. So let's see. 83. All right. And in fact, that's what the case is. So what happens here is that cout looks at the type of the thing that's passed in. So char is not the same as int, but characters are integers. That seems contradictory, isn't it? So char is not an int, but a character is an integer. Okay, Ryan's lost his mind, right? So why is that true? So char and an int are what are called different types. So they're different types in the C++ language. If we wanted them to be the same, wouldn't we just all work with integers instead? So what happens here is cout looks at the type of the thing passed in. So it says, okay, this C thing that I'm being passed in, that's a char. So therefore, I print the character of it. But if I had cn.get over here, what does cn.get give me? An integer. So cout says, oh, you have an integer to give me. I'm going to print the integer, not the character. So if we did this instead, so let's do cn.get to the actual character again, and then print out that character. Now it's going to do exactly what we want and print CS. Okay? So the types of the things that are passed in are actually kind of important. So just remember that a char is not the same as an int, but a character and an integer are the same thing. They're represented the same way. Yeah.
What if you want to like get a string from the user, but it's limited to a certain amount of words? Does that make sense?
So you are limiting how many characters the user can enter.
Yeah.
Yeah, I think I have a slide about that. Let's see. Okay, so I don't have a slide about that, but we'll maybe encounter something called a substring. So what you do there is say, so I'm going to take the entire input. I'm going to get the entire thing, but I'm going to chop off the rest of it after like the 100th character or whatever you need. So you can actually get rid of that. So I actually don't remember exactly how to do that, but I'll look and see. But there is a way that you can chop off exactly what part of the input you want. Maybe you want from the second character to the 5th character and not include the first one. So you would think, well, how do you actually do that? So maybe there is a way. So let's see. So let's do a normal string. You guys ask really good questions. Please keep that throughout your degree. All right, so let's CNS, then S dots. So the way that you can see what types of things you can do on a string, you do S dot, and then you can actually scroll through all of the operations that you can do. So I think there's a find, no, compare. Okay, I don't see a way directly, but I'll look it up and see. If you look at substring for C++, there should be a way to do that. I think there should be a substring. Yeah, okay, here it is. So this is exactly what I want. So this subster function tells you what is the index that you want to start the resulting string from and where you want to go to. But then we'll have to talk about indices, but we haven't really talked about that yet. So just be cautious if you want to use this function. Yeah. So cn.get and then what? Oh, okay. So if we actually look at .get, then if we look at all of the different types of functions we can have, then there's one right here called that has get here. Let's see. I actually haven't used this before, but let's try your suggestion and say I want to get 5 characters. But remember that this gives us a string back because if I have more than one character, then I need a string. So if I have string S here, then, okay, yeah, so that's not the function. So what was your suggestion? Oh, okay, okay, I see what you mean. So if we go back to what we had before, oops, come on, work with me. So if we wanted a specific character, yeah. So if we wanted a specific character, then what we would need is something called the square bracket operator. So if we wanted to see out the second character, we would actually need to print S of 1. So square brackets 1. We haven't really talked about arrays yet, but that's how you do it. So if we wanted to print out the second character of this thing, then it would print S like this. So, but we haven't talked about that. I don't expect you to know this yet. Other questions?
Yeah, how do you get back, like, how do you, like, turn back what you did? Like, you know how in a Word document you can go back?
Yeah, just Command Z if you're on a Mac or Control Z if you're on Windows. So you can do undo exactly the same way. You have to be in the editor for it to work, but yeah, I just do Command Z, undo. Other questions? Oops. I don't know what's happening with that, but okay. So if we wanted to get a character, then we can do cn normally, or we can use get here to make this easier, more clear for us. But so another way you can do it is, so here we're not doing an assignment to ch. It's going to be saved into ch, but if I do get here, I can do an assignment directly. It does the exact same thing. Yeah, so if you do cn.ignore, then if you want to ignore a character, that's the way to do it. So so this is actually related to someone's question, I forget who. If you want to ignore, say, like the first 5 characters the user enters or from wherever, then this is a way you can do it. So it tells you the number of characters you want to skip, and then if you happen to encounter a particular character, just stop there. Yeah, and ignore without the parameters to this function, skip a single one. But more often than not, we're going to be working with strings anyway. So one thing you may want to know is, how big is this string? So the length function is the way that you can check. So if we have a string here, George Washington, then if I call that string dot length with parentheses and nothing in the parentheses, that gives me back an integer to say, what is the size of this thing? So what do you think the number of so why is it 17 in this case? Yeah. Yeah, it counts space as a character. Well, let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. But isn't there something else in a character too, in a string too? The null terminator. So shouldn't it give me 18 here? Because that is a character. So this is, again, part of the artistry. Should you include that character or should you not? So it seems better to not include it because the vast majority of the time, we're not going to be working with that character anyway. But you may imagine you may want to work with that character. So you would have to design your length function to be able to work with that particular use case. But the vast majority of us don't work with that. Yeah, so it doesn't include the null terminator. But if I wanted to change the string, so if I have a string like George Washington, and I wanted to, okay, so yeah, if I wanted to assign a particular character in a spot, or if I wanted to add a particular character, some number of them, to a string, then assign is the way to go. So if we have any string, it doesn't matter if it's initialized or not, then you can say, well, I'm going to add 80 equal signs to this string. So if I do this code right here, so if I just do this, and then I see out the entire string, and not string, equals. Because I gotta print the variable, not string, because that's a different thing. So it actually prints 80 equal signs, which is exactly what we want. I've never used this function, but it definitely could be useful if you want to print maybe like a menu bar like this to differentiate some output from some other output. Okay, so if you want to extend a string by a certain character some number of times, assign's the way to go. Okay, one more slide and then I'll let you go for the weekend, long weekend. So one of the most important concepts that we'll see the entire class is this thing called a bool. So what is a bool short for? Does anyone know? Boolean. So what is a Boolean? It's actually a 1 or a 0. Good. So but you can also represent it in C++ by true or false. So if I want something to be true, then I assign some bool to have the value true, and otherwise I assign it to be false. So in C++, like characters, booleans are also integers. So you can work with 0 or 1 if you like, but it's a lot easier to read if you have false or true. So if I initialize 2 bool variables, one of them called alldone to be true, then on the back end it's going to hold the value 1, and then another one, if I set it to be false, then it's going to hold the value 0 on the back end. So why is this important? So does anyone know why bools are important? Like the singular most important thing we'll see, because it'll be the foundation for everything else we'll do in the class.
Because you're going to be doing a lot of comparisons, and if the comparisons tree.
Exactly. Anyone looked at the second assignment yet? Yeah. So one of the on the last question, the programming question, I ask you to print something if some condition is satisfied, print something else if some other condition is satisfied, that sort of thing. So right after this set of slides, we're going to be talking about conditionals. And what those are testing if some condition is true. So if this condition is true, execute this block of code. But if it's not true, execute this other block of code. And the way that those conditions are said to be true or false are with bools. So we evaluate this condition. The result is going to be a bool. It's going to be true or false. And then we'll see, then we execute this block or this block. What if we wanted to repeat a certain block of code over and over and over, maybe 100 times? How would that work? Yeah. Yeah, we'll talk about loops. So how does a loop work? What happens is, if we wanted to repeat this block of code 100 times, let's say, then we'll have a counter that says, the counter starts at 0, which means we've not done this code any number of times, and every time we go through the code, we add 1 to this counter. Well, how do I know when to stop? When the counter exceeds 100. Well, how do I know if that's true? With a bool. I make a check, is this counter at least 100? And so the bool situation here is going to be the foundation of everything else we'll do in the class. So if you understand true and false, you should be at least good to the rest of the class. Any questions otherwise, though? Great, have a good long weekend. No class Monday.